Alrighty, we are going to be starting our target or our KC2 notes today. And so you can find these on our Teams page under the left-hand side, KC2. And we're going to be talking about trigonometry. And so starting with this first page of notes, we're going to be using trigonometric ratios to find the length of unknown sides and angles. And so first things first, we need to talk about the trigonometric functions. And we have three functions. We have sine. So this S stands for sine. We have cosine, and we have tangent. So these are just functions. These are going to be buttons in our calculator. They just are what they are, so just know that. We have sine, cosine, and tangent, sine, cosine, and tangent. And then we're also going to be talking about this symbol right here. You will see us talk about it a lot today. It's kind of like an oval with that line kind of towards the top. And we call that theta, and this is going to represent an angle. So that's going to represent an angle. So anytime we're talking about theta, we'll be talking about an angle. And with that being said, sine, cosine, and tangent, we can find those by making fractions. And so these fractions are going to be equal to the sine of something. The sine of an angle is going to be equal to the opposite over the hypotenuse. And I know this doesn't mean anything yet, but just write this down and we'll tie it together. The cosine is going to be equal to the adjacent side, oopsies, adjacent over hypotenuse. And the tangent is going to be equal to the opposite side divided by the adjacent side. And you're probably thinking, wow, Miss Bishop, you're so cool because you have this memorized. You must be super smart. No, I have this memorized because of this here. Do not overlook or underestimate how important this is. We call this, you will hear me refer to this as SOHCAHTOA. SOHCAHTOA. And you're thinking, what the heck? But this is actually going to become very important. SOHCAHTOA is a way for me to remember this information below. This S stands for sine. Sine is equal to the opposite over hypotenuse. So this is a way to help you remember the fractions. Sine is equal to opposite over hypotenuse. Then cosine. Cosine starts at the letter C. So I go to the C part of SOHCAHTOA. Cosine is equal to adjacent over hypotenuse. And that's what I have there. And same thing with tangent. Opposite over adjacent. So if you could just remember how to say and spell SOHCAHTOA, you will be able to remember how to do these fractions every single time. One thing to point out for that is, what is opposite, hypotenuse, and adjacent? Well, if we use this picture right here, we are going to explain what that means right here. So first things first, your hypotenuse we talked about in the first unit, that's always going to be across from your right angle. And we're going to be using right triangles in all of these problems. And my hypotenuse is always across from my right angle. So my right angle happens where I have that L, where the completely vertical line meets that completely horizontal line. So I'm going to put in my right angle because the side across from that is my hypotenuse. Now my opposite and my adjacent, those depend on where my theta is going to be. So here's that theta. That's this angle right here. That represents an angle. And this is my reference angle. So we're going to call this my reference angle. That's my reference angle because my opposite and my adjacent depend on where this angle is. So for my opposite, I'm going to go to the side opposite from theta. So here's theta, my reference angle. The side across is my opposite side. And then by process of elimination, or you can remember that adjacent means next to, my side next to my theta is my adjacent side. So when we start every single one of these problems, we're going to just start off by labeling opposite, adjacent, and hypotenuse. Notice when your theta is somewhere else, when your theta is maybe over here in this corner, my opposite side is going to be on this side now because my opposite side is always across from my theta. So your opposite and your adjacent are going to switch places depending on your reference angle. But your right angle, your hypotenuse, will always be across from your right angle.